If f of x is the rational function 1 over x plus 1, let's look at how to find f composed of f of x. So the idea of what's going to happen here is that we're going to take 1 over x plus 1 and then we're going to put it back into itself in place of the variable x. So it's like taking f of 1 over x plus 1. So when we have our function 1 over x plus 1 in place of the x, we're going to put the whole function 1 over x plus 1, then we still have our plus 1. So we've done the composition. Everything from here on out is just to try to clean this up and make it a little bit easier to work with. So the first thing that I'm going to work on doing is getting so that I have just one fraction in the denominator instead of two separate terms. So to be able to do that, I need a common denominator of x plus 1. So I'm going to take this constant term of 1 times x plus 1 over x plus 1. So now I have 1 over x plus 1 plus x plus 1 over x plus 1. So now I can combine those two fractions in the denominator since they have the same common denominator. So we have 1 plus x plus 1 all over x plus 1, or we could write that as 1 all over x plus 2 all over x plus 1. So dividing by a fraction is the same as multiplying by its reciprocal, so this is the same as 1 times x plus 1 over x plus 2, or just x plus 1 all over x plus 2. So this is going to be our function. This is what f composed of f of x is equal to. So the one other thing that it asked about was domain as we're thinking about this one. So values of x that we need to exclude when we do this composition. So if we think about our original function f, the domain of this function f of x, since it's a 1 over x plus 1, x plus 1 cannot be equal to 0. So that means x cannot be equal to negative 1. So since we're going to start with the original function f, we need to make sure that we still exclude that negative 1. If you look at the simplified answer that we have at the end, we also see that x plus 2 in the denominator. So when we're looking at that x plus 2, we're also going to need to make sure that x plus 2 is not equal to 0. So x cannot be equal to negative 2. So our domain for this composition, f composed of f of x, we're going to need to throw out two values. The x's cannot be equal to negative 1, because that would be a problem on the first step. So we need to make sure that we don't pick out negative 1 on that first step. So as long as we pick something not equal to negative 1, we won't have a problem on the first step. But then we need to make sure that when we take that and plug it back into our function, that we also are able to do that. And so that's what we can catch from that simplified answer that we have at the end. So we can catch kind of 1 at the beginning and 1 at the end. So not equal to negative 1 and not equal to negative 2 as well.